Hello viewers, we continue with our lesson with programming with C++. We'll be talking about the introduce to C++ types, learning the fundamental types such as the Boolean, character types, integer, floating points, void, and so on. So let me try to explain some few tips here for my viewers to understand. When we talk about the Boolean, it simply means the true or false values. But in this case, since the computer is compute to binary operations and stuff, it doesn't understand any letters or stuff. So it is programmed to either 0 or 1. So when it's 0, it's false. When it's 1, it's true. That's the Boolean. We talk about the character types. It's for mostly letters and symbols. We talk about integers, how it's basically explain itself a whole number. We talk about floating points, it deals with decimal numbers. We talk about the void, it also deals with a special type that represents nothing. It represents nothing. So let's move on to let's continue. When we talk about introduce to declaration, it simply means how to tell the computer what kind of data you want to work with. What kind of data you want to work with. So we will learn about the structure of declaration, the proper way to write them, and the proper way to write declaration, how to declare a variable. We'll talk about that when we go for it. So, and also we have something like declaring multiple names, how to create several variables at once. We also talk about that in the practical section. You practice it for today, so don't worry. And the name scope too. Okay, understanding where variables can be used in your program. We also do that, and we talk about the initialization. It simply means how to give your variables starting values. So let's proceed to data types. Let's proceed to our data types. There are several data types in programming language. So I like to talk a few about these data types. So simply means we have to know the definition of data types, what is meant by data types, so that everyone will get a clear understanding about data types. When we talk about data types, it refers to various forms that data can be represented in a programming language. Think of data types like different containers in your kitchen. You have containers for liquid, I'm citing an example, containers for solids, containers for small items, and containers for large items. Each container is designed for a specific purpose. That's how the data type is. With this, the data types that we've listed here, that's the integer, floating point, the Boolean, and other stuff. It's basically used for different things. It serves different purposes, but they are all data types. But here is the case, they serve different purposes. So let's proceed. So now we are moving to the categories of data types. With the categories of data types, that's what I've listed them here. We have the integral data types. That's we have the integer, character, and Boolean. And we have the integral and floating point. Those types are called the arithmetic types. If you see arithmetic types, it simply means the integral and floating point. And you have the enumeration and classes are also called the user-defined types. So if in case you don't see enumeration and classes, you can also see user-defined data types. Sorry. We have the fundamental types. That's the pointers, the references. They are all called built-in types. So let's proceed. So let's move on to data set. So basically when we talk about this data set, we said each data has what we call a data set. This is the range of values that the data type can represent. Think of it like the capacity of different containers. So that is specifically the data sets. It specifies the range of values that data is composed of. That's what you call the data set. So uh, I would like to cite an example of the data set I just said. So with this, we can have example like a small cup can hold a certain amount of liquid. A large bucket can hold much more. Yeah. So these are some practical, let's say, lifetime examples of data set. So now let's proceed. So now let's move on to the integer as a data set. So the integer, as I once said, simply means a whole number or numbers. So integer data type can hold whole number, both positive and negative. So example, we can have the negative 1000, 0, 42, and blah blah blah, as you can think of. And we also have the floating point as a data set. What we said is that it involves a decimal number. So anytime you see a decimal number in programming, its data set we have the floating point. So example is like 5.2, 8.9, and stuff. So we have, okay, let me specify this. With the floating point, we have decimal number with single precision. And we have floating point, that is double, decimal number with double precisions. So when we get to the practical section, you get to know about all this. So let's move on to characters, boolean, and strings. So with characters, one said it really entitles with letters, numbers, and symbols. So with character, we put it in a single quote. Characters are being placed in a single quote. Yeah, single quote. And also we demonstrate all this in the practical section we get. And when we talk about boolean, it deals with the true or false. And we talk about the strings. They are data type that can hold combination of characters, essentially text. Examples include the hello. That's strings are written in double quotes. That's when writing a C++ program. Now let's move on to the data size. Understanding data size. So data size refers to how much memory each data type uses. So this is important because one, memory is limited. The memory is limited, and you have to different operations have different speed requirements. And three, understanding the size helps you to write efficient code. That's the data size. So that's the size of each data set that is allocated to each data type. So let's move on to the integer. So with the integer, its data size is 4 bytes. With the floating point, it uses 4 bytes. With the floating point, that's the double, it uses 8 bytes. That's why I said we have the single precisions and we have the double precision. So with the floating point, the single precisions, it uses 4 bytes. The double precisions uses 8 bytes. We have the character. The character uses 1 byte. The boolean uses 1 byte. The strings uses 32 bytes. So these are all data size that we have. So now let's move on to integer types. as earlier we said, integer deals with positive and negative whole number. So let's dive deeper into integer types. Integer are whole number, as I said, with no decimal points allowed. So examples is what you see on your screen. That's the negative 6,728 is a integer type because there's no decimal point in it. Earlier on we said integers are positive and negative whole numbers. So that's why you can see a negative number as an integer type. And we have 0, we have 78. All these are all examples of integers. Also, we have types, integer types. So these are clearly a practical section of the integer types. So these are a standard library, that's the preprocessors. So this one is int x equals 25. That's an integer type because it's a whole number. It doesn't involve any decimal or any kind of point in it. So now let's move on to the floating point data types. So with the floating point, types are used to represent numbers with decimal. As we said earlier, they are decimal numbers. They are decimal numbers. Yes. So with the C++ has three floating point types. Thus we have the float. That's the single precision. So it's about 7 decimal digits. That's the single precision. That holds 4 bytes. As we said earlier, we have the double precision. That's it holds about 15 decimal digits. We have the long double. That's extended precisions. Even more precisions. It's when we talk about extended, it goes like it can hold, really holds. So these are the practical examples of the float types. We demonstrate it in our coding section when we get to the practical section. These are all double types. Now let's move on to the Boolean types. As we said, Boolean are either true or false statements, and we said it is known as bool, and it has only 2 values. That was either true or false. But in this case, since the computer deals with binaries, it is represented by 1 or 0. That is, if it is true, it is 1 or yes. If it is false, it is represented by 0 or no. That's for the Boolean. So these are practical examples of this. When we get to the practical section, we'll demonstrate that. Let's move on to the character types. So when we talk about the character type, it represents the smallest integral data type in C++. They are used to store single characters like letters, digits, or symbols. The key rule for character types. So we have some rules we have to abide when declaring or writing a character type. So I'll try to glance through that rule for you to get a clear understanding about it. So the character type, it said each character is enclosed with a single quote. That means when you declare a character type, it should be in a single quote, else your code is wrong. And also, a blank space is a character. That's space between single quotes. We have characters can include letters, numbers, and symbols. So it doesn't matter. It's like a universal something. Let me put it in that way because it can include letters, numbers, and symbols. So when we get to the practical section, I'll demonstrate it to my users. Now let's move on to the string types. So with the string type, they are simply written in a double quote. Yeah, they are simply written in a double quote. So here are some key characteristics of a string data type. So we have they can contain 0 or more characters. They are enclosed in double quotation marks. Any empty string is called null string. Yes, so any empty strings without character but have its double quote is a null string. So we demonstrate that in our practical section. So let's move on to the void. As is one said, it represents a special they are unique. Let me put it in that way. Void are unique. They are unique. So when we talk about the void, okay, it signifies the absence of information. Think of it as representing nothing or no value. So as I once said, they are unique. They are special purpose functions. They are very unique. And we have some key characteristics of void. So that's we have it's syntactically a fundamental data type. That's the key characteristic of void. It can only be used as part of more complicated types. It's mostly used with functions, and it cannot create a regular variable of type void. That's the void. So these are practical examples of the void. So we will demonstrate that in our practical section. Let's move to the sign and unsigned. So sign and unsigned are type modifiers that affect how numbers are interacted. Okay, they affect how numbers are interacted. That is the sign and unsigned. So let's break it down. Let's talk about the sign and we talk about the unsigned. So when you talk about the sign is a type can represent both positive and negative values. With a sign, it represents both positive and negative. And with the unsigned, can only represent non-negative values, that's 0 and positive values. That's with the unsigned. It doesn't deal with a negative stuff. It only deals with a 0, that's nothing, or positive values. That's the use of the unsigned. So these are practical example of it. So you continue with other fundamental types. So the C++ provides several other fundamental types with different sizes. Thus, we have the short, that's 2 bytes. We have the long, that's 4 bytes. The long, that's 8 bytes. And we have composite types. So composite types overview there. Beyond fundamental types, C++ also has composite types, which are built from fundamental types. So we have the pointers, we have the arrays, we have the reference type. So when we talk about the pointers, variables that stores memory address. Yeah, and we have the arrays is a collection of elements of the same type. And the references simply means the aliases for existing variable. That's aliases. Yeah. So let's move on to the user defined types. Let's move on to the user defined types. So with the C++ always allows you to create your own custom types. Thus, we have the data structure and classes. You can group related data and functions together. That's enumeration. You can create types that represent specific set of values. So let's move on. So let's move on to declaring multiple names. Declaring multiple names. So sometimes you need several variables of the same type. That's why we have declaration and we have declaring multiple names to make your work easier if you are declaring a certain variable to prevent long-term work. That's why we in the C++ program we can declare multiple names and declaring multiple names. So let's talk about that. So we said sometimes you need several variables of the same type. Instead of writing separate declaration, you can declare multiple names in a single declaration using commas for separation. So the commas is very necessary in this point when you are declaring multiple names. Without the commas, it's assumed as one declaration. So the commas separate what we are doing from the other. So these are all practical examples of declaring multiple names. We'll do that in our practical section. So now let's move on to the scope, or understanding the scope. We have the local scope, global scope, class scope, namespace scope, statement scope. So scope basically refers to the region of your program where a variable can be accessed. Sorry. Thinking of scope like the range of wireless signals. It works within a certain area, but not beyond. That's what I said. C++ has several types of scope. So with the local scope, variables inside functions or block. That's for the local scope. The global scope, variable outside all functions. The class scope, variable inside classes. With the name scope, variable inside namespaces. And with the statement scope, variable inside a specific statement. Thus, understanding scope is crucial for writing organized bug-free codes. It's very necessary that you have to take note of. So these are all practical examples of the scope I just mentioned. Yeah. So now let's move on to declaration of variables, how to declare a variable. So in C++, an identifier must be declared before being used. So this is like introducing yourself before having a conversation. The compiler needs to know what you are talking about. declaration informs the compiler what kind of entity the identifier refers to. It answers the question like. So let me chip in this. So these are all declaration of functions. This is how you declare a function. So this is our practical example that we'll be looking at. Let's move on to the initialization. Initialization determines the initial value of an object. It's like setting the starting position for a car's odometer. You are giving it a beginning value. So this is the initialization. These are all examples of initialization. So this is a practical example of initialization. Mostly it uses the equal to sign when you are initializing a particular function. So we come to the end of our section, and I want us to have a clear view of our practical section in these tutorials. So this, I've opened my code blocks, and we will practice on all what we just said about the data types. So let's I'm coming minutes. Okay, we will talk about the integer types. That's how to write an integer type in the C++ programming language. So this is it. This has to include blah blah blah. We talk about it in our week 1 lesson. That's the preprocessors. So now let's declare an integer type. So let me say int x equals 25. You terminate it. And so this we've declared an integer type. And let's move on to the floating, how to declare a floating type. So let's have float amount. Float amount equals, since float deals with decimals, we have to include decimals. So we have 12.3 we terminate. So this is an example of a floating point data type. And floating points for more precisions. As we said, we have the single precisions, double the precisions, and long precisions. So let's proceed. So we have double. We have the double salary, that is equals 125.444455. We terminate. That's our, this is the more floating precisions, like more precisions with more decimal points. And we have, let's move on to the boolean. So let's move on to the boolean. So we have boo, so it can also be represented as boo. Boo is raining. It's raining. I think there's a mistake. It's raining. So true. They terminate. This is the boolean functions. And we have boo pass homework false. We terminate. These are all examples of the boolean functions. Now let's move on to the character types. We said to declare a character, it's placed in a single quote. So let's talk about that too. So we have we have character types. Let me comment this for you to have it clear. So we have car equals m. So they said with this, if you run it, is an error because you have to put it in a single quote. So let me bring my single quote. Terminate. This is a character type. And let's move on to a string type. Let me declare it here. Strings. Here we have string name equals Amma. But with this, if you run it, get an error because we said the string, it deals with double quotes. Let's put our double quote. There's it. We terminate. So let's move to the signed and unsigned. So let's have signed. Say the sign, it deals with positive and negative. So let me give signed int temperature. So negative 13. It's correct. because, and it can also be sine int balance. They are all correct since it deals with negative and positive. We are seeing the on sign. It deals with only positive numbers. Say unsigned, let's say int. So that's the unsigned. It deals with positive, only positive numbers. So let's talk about declaring multiple variables. So multiple declaration. It could be int x. It said it's repeated by comma, y, comma, and z. This is an example of declaring multiple values. Let's move on to initialization. Now int age equals 25. That's initialization, initialing a variable. So I think this is the end of our section. We will continue on with the other section, that's next week. Thanks once again. I'm Eric Atifa, your lecturer for this tutorial. Bye.